Hello dear students. In our last session we learned about the laws of photoelectric effect. We discussed totally 5 laws. In today's session I am going to explain main important concept, that is the Einstein photoelectric equation. Albert Einstein photoelectric equation. And by using this equation, we are going to explain the photoelectric effect observations. Already know, Albert Einstein explained the photoelectric effect by using Max Planck's quantum theory of radiation. According to Max Planck, light energy consists of a minute particle. That minute particles is called as quanta, or also called as photon. Each photon energy is considered as E is equal to h nu. E means energy and h is a Planck's constant and nu means a frequency, is equal to h nu. When that photon energy falls on the metal plate, on that metal plate's electrons are present already know. That electrons absorb that energy and escape from that metal plate. And when it escape from the metal plate and that electrons moves towards to the unknown plate and current will be generated in the circuit, that current we call as photoelectric current. Okay, this is the main concept of a Einstein photoelectric effect. Then here that energy is equal to h nu energy. Here we are used in two ways. Okay, two ways. First one part. A part of energy it is used to liberate the electron from the metal plate, and remaining part of energy it is used to increase the maximum kinetic energy of the liberated electrons. It means we have increased the speed of liberated electrons. That is called as photoelectrons. Photoelectrons. Here, first photon energy that is E is equal to h nu. Photon energy E is equal to h nu is used as two ways. It is used as two ways. Way one, part one, first one. A part of energy used to liberate electrons from metal plate. Here minimum energy required to remove the electron from the metal plate, that is called as work function. It means 50% of that photon energy is used to remove the electrons or to liberate the electrons. That is called as work function. For work function purpose, we have used 50% of photon energy. Okay, a part of energy used to liberate the electrons from the metal plate. It means that is the work function. That is work function. Then remaining part of energy. Here 50% over. For example, I am considering E is equal to h nu. It is a 100% of energy. 100% of energy. In this 100% of energy, 50% of energy it is used to liberate the electrons. from the metal plate. It means 50% of energy it is used for work function. What is the meaning of work function? Minimum energy required to remove the electron from the metal surface. For example, this one is one metal surface and this one is one electron. When U is equal to h nu of energy falls on the metal surface, at that time out of that 100%, 50% of energy it is used for work function. Work function nothing but minimum energy required to remove the electron from the metal surface. Minimum energy required to remove the electron from the metal surface is called work function. Then remaining 50% of energy. The remaining 50% of energy, remaining energy used for increase maximum kinetic energy of liberated photo electrons. Remaining 50% of energy is used to increase the kinetic energy of the liberated photo electrons. So here, this one is a very important question for 5 marks. Write Einstein photoelectric equation using this. Explain the experimental observations of photoelectric effect. Okay. Now, by using this one equation, how do you know work function equation? Work function phi is equal to h nu naught, and photon energy equation E is equal to h nu. Kinetic energy equation of mv square. By considering these two parts, I am going to write the equation. Here photon energy, that is the total energy is equal to 50% of energy is used for work function, phi naught. Remaining energy is used for kinetic energy, that is the maximum kinetic energy. But we know that E is equal to h nu and phi naught is equal to h nu naught. E energy, h Planck's constant, nu frequency. Here phi naught means work function, h Planck's constant, nu naught threshold frequency. Then substitute these values in equation number 1. H nu is equal to h nu naught plus kinetic energy maximum. Therefore, kinetic energy maximum is equal to h nu minus h nu naught is equal to h common, h is equal to nu minus nu naught. Okay, this equation is called as Einstein photoelectric equation. Here kinetic energy maximum is equal to h nu minus nu naught. This equation is called as Einstein photoelectric equation in terms of normal frequency and threshold frequency. Then this equation again conversion in the form of wavelength. See, kinetic energy is maximum is equal to h nu means frequency, nu naught means it is a threshold frequency. threshold frequency. Then we know that C is equal to nu lambda, or nu is equal to C divided by lambda. This will be called as normal frequency in terms of wavelength. And convert this to the form of threshold wavelength in the threshold frequency C divided by lambda naught. Nu naught it is called as threshold frequency and lambda naught is called as threshold wavelength. Substitute these two values in above equation. Kinetic energy maximum is equal to H in the place of nu C divided by lambda minus in the place of nu naught C divided by lambda naught. Then final equation, kinetic energy maximum is equal to C also common, HC remaining here 1 divided by lambda minus 1 divided by lambda naught. Okay, this equation we call as photoelectric equation in terms of wavelength. Normal wavelength and threshold wavelength, and this equation we call as kinetic energy of a photoelectric equation in terms of normal frequency and threshold frequency. Here H indicates that is called as the Planck's constant. Okay, up to here I have explained only kinetic energy equation, Einstein equation, Einstein kinetic energy equation. The next one, observations. By using these equations, okay, we write the observations. Next, experimental observations of a photoelectric effect by using Einstein photoelectric equation. Dear students, already know Einstein photoelectric equation, that is kinetic energy maximum is equal to H nu minus H nu naught. H nu minus H nu naught. This is the photon energy and this one is the work function. Work function. Okay. Here, first one observation. Photoelectric effect is an instantaneous process. It is an instantaneous process. So here, photoelectric effect is due to the absorption of a light quantum by an electron, which is an instantaneous process. It means when UV radiation, photon energy is equal to H nu energy falls on the plate. On the plate, electrons are present now. That electrons absorb that energy, and within a fraction of a second, in the 10 to the power of minus second, that electrons are liberated. Okay, it process is going on continuous. When UV radiation falls on the plate, electrons are liberated. That is the instantaneous process. It is the first one. Photoelectric effect is an instantaneous process. And second one, when you increase the frequency of radiation, it means above the threshold frequency. Okay, when we increase the frequency of incident radiation or photon energy E is equal to H nu. When we increase the frequency continuously, at that time kinetic energy of the liberated electrons also increases. Whenever we increase the frequency of incident radiation, at that time liberated electrons kinetic energy also increases. Okay, second point. Observe here the maximum kinetic energy of the photoelectrons. Photoelectrons, nothing but here liberated electrons increases linearly with the frequency of incident radiation. It means when you increase frequency of radiation, at that time kinetic energy of the photoelectrons or liberated electrons increases. Okay, this one is the second one observation. And third one, kinetic energy is always positive. Kinetic energy is always positive. Therefore, H nu minus H nu naught must be positive. Hence, photoelectric emission is possible only H nu greater than work function phi naught. See here, kinetic energy is always positive. Therefore, H nu minus H nu naught must be positive. Okay, this one also must be positive. Hence, photoelectric emission is possible only H nu is greater than work function. It means minimum work energy is required to remove the electrons from the metal plate, that is called as work function. Okay, work function. Their energy when it is greater than the work function, at that time photoelectric emission is possible. Okay, this one is the third one, experimental observation of a photoelectric effect. Okay, notably kinetic energy equation, photoelectric equation. Kinetic energy is equal to H nu minus H nu naught ಅಂತಿದೆ. ಇದು photon energy, ಇದು work function. ಈ ಒಂದು ಈಕ್ವೇಶನ್ ಕನ್ಸಿಡರ್ ಮಾಡಿಕೊಂಡು ನಾವು ಮೂರು ಲಾಸ್ ಬರೆದಿದ್ದೀವಿ. ಫಸ್ಟ್ ಲಾ ಏನಿದೆ, ಫೋಟೋ ಎಲೆಕ್ಟ್ರಿಕ್ ಎಫೆಕ್ಟ್ ಏನಾಗಿದೆ, ಇದು ಇನ್ಸ್ಟಂಟೇನಿಯಸ್ ಪ್ರೊಸೆಸ್ ಇದೆ. ಯಾವಾಗ ಫೋಟಾನ್ ಎನರ್ಜಿ ಮೆಟಲ್ ಪ್ಲೇಟ್ ಮೇಲೆ ಬೀಳುತ್ತೋ ಆವಾಗ ಇದ್ರ ಮೇಲಿರುವ ಎಲೆಕ್ಟ್ರಾನ್ ಆ ಎನರ್ಜಿ ಏನ್ ಮಾಡ್ಕೊಂತೀವಿ, ಅಬ್ಸರ್ವ್ ಮಾಡಿಕೊಂಡು ವಿದಿನ್ ಫ್ರಾಕ್ಷನ್ ಆಫ್ ಸೆಕೆಂಡ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಎಲೆಕ್ಟ್ರಾನ್ ಲಿಬರೇಟ್ ಆಗುತ್ತೆ. ಯಾಕೆ ಈ ಎಲೆಕ್ಟ್ರಾನ್ ರಿಮೂವ್ ಆಗೋಕೆ ಇದ್ರ ಮೇನ್ ಕಾರಣ ಏನಿಲ್ಲಿ, ಇನ್ಸಿಡೆಂಟ್ radiations. Okay, then second one, in second one ಏನು ಹೇಳುತ್ತೆ, ಯಾವಾಗ ನೀವು ಫ್ರೀಕ್ವೆನ್ಸಿ ಇನ್ಕ್ರೀಸ್ ಮಾಡುತ್ತೋ, ಇನ್ಸಿಡೆಂಟ್ ಲೈಟ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಇನ್ಕ್ರೀಸ್ ಮಾಡುತ್ತೋ ಆವಾಗ ಲಿಬರೇಟೆಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಏನಾಗುತ್ತೆ, ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಯಾವ ತರ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ, ಲೀನಿಯರ್ಲಿ. ದೆನ್ ಥರ್ಡ್ ಒನ್, ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಏನಾಗುತ್ತೆ, ಆಲ್ವೇಸ್ ಪಾಸಿಟಿವ್. ಯಾವಾಗ, therefore H nu minus work function nu naught must be positive. Hence, photoelectric emission is possible only H nu greater than work function. ಯಾವಾಗ H nu photon energy greater than work function ಇರುತ್ತೋ ಆವಾಗ photoelectric emission ಏನಾಗುತ್ತೆ, ಪಾಸಿಬಲ್ ಇದೆ. ಓಕೆ, ಈ ಮೂರು ಎಕ್ಸ್ಪೆರಿಮೆಂಟಲ್ ಅಬ್ಸರ್ವೇಷನ್ ಕಂಪ್ಲೀಟ್ ಆಯ್ತು. ಇನ್ನು ನೆಕ್ಸ್ಟ್ ಇನ್ನೊಂದಿದೆ, ಅದನ್ನ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ. And last one law, intensity of radiations, incident radiation, intensity of incident radiation, okay, increases at that time photoelectric current also increases. That two are directly proportional. Okay, see here, along x-axis I am considering intensity of incident radiation and y-axis side photoelectric current. That current related to the symbol I. Okay, when increases intensity of incident radiation, at that time current also increases in the circuit. Okay, we obtain that linear graph. Okay, that linear graph indicates that two are directly proportional with each other. Okay, observe here, photoelectric current, that is the I, is directly proportional to the intensity of incident radiation. Okay, here cathode and anode plate are there, cathode and anode, that two are connected to a battery, and again it is connected to the galvanometer or microammeter. When you incident the UV radiation of the cathode plate increases intensity of incident radiation. When it increases incident radiation intensity, at that time more electrons are liberated means here current also increases in the circuit. That current we are detected or measured by using microammeter. Okay, these are the main laws of photoelectric effect that are explained by using Einstein photoelectric equation. Okay, this one is a very important derivation for 5 marks. Already they asked 2015 and 16 year.